Calculus Kcse 2016 paper 2 question number 23. So the question reads, the equation of a curve is given by y is equals to 2x cubed plus 3x squared. Find part 1 of the question, the x-intercept of the curve, then the y-intercept of the curve, then determine the stationary points of the curve. Don't mind the numbering of the question, it is wrong, that is not the most important thing. Then the other question, for each point in B above, determine whether it is a maximum or a minimum point. And then the last, sketch the curve. So those are the questions. As I've said, don't mind the numbering is wrong from Roman 1. The most important thing is the question. Now, the first part of the question is the x-intercept of the curve. Now, for the x-intercept, we should know that at x-intercept, y is equals to 0. At x-intercept, y is equals to 0. X-intercept is the point where the curve cuts the x-axis. That is, we should just substitute in the curve, the equation of the curve, where we have y, we substitute that one is 0. And we do that, 0 is equals to 2x cubed plus 3x squared. So that is what you equate to 0. So when you do that, this is what you get. 0 is equals to, we factor out x squared is common into 2x plus 3. Then after factoring out what is common, the next thing we're going to do is get x squared is 0, and then for that x will be 0, and then the other one is 2x plus 3 is equals to 0, and in this case x is equals to negative 3 over 2. Since when you're multiplying two numbers and the product is 0, then x squared should be 0, or 2x plus 3 is equals to 0. So the values of x-intercepts are 2. There are 2 points where the curve cuts the x-axis at x is equals to 0 and at x is equals to negative 3, 2. However, we can still give that point where the curve cuts the x-axis. The first point is 0, 0. Remember, the value of y at x-intercept is 0. So the other one is a negative 3 over 2, 0. Now let's go to the y-intercept. Now for the y-intercept, we should start by saying that at y-intercept, the value of x should be 0. At y-intercept, x is equals to 0. Therefore, we just need to take the equation of the curve, and where we have x value, we substitute that x value with 0. So let's take the equation. So y is equals to, y is equals to 2x, okay, 2x cubed plus 3x squared, 2x cubed plus 3x squared. So we substitute because we say that y-intercept x is 0. So when x is equals to 0, y is given by 0. That is what you'll get. When x, substitute x is equals to 0, y is equals to, therefore, the y-intercept is 0. And if you give that point at which it cuts the y-axis, it will be 0, 0. So I'm giving the intercepts and the point. So those are the intercepts, x-intercepts, there are 2. X is equals to 0, x is equals to negative 3 over 2. And then the 2 are the points that I've given. The 2 are the points. Now let's go to the other part of the question. Determine the stationary points of the curve. The stationary points. So at stationary point, the gradient, that is dy over dx, is 0. At stationary point, dy dx is 0, or the gradient is 0. So therefore, we take the equation of the curve, y is equals to 2x, this is a 2x cubed, forgetting this equation, 2x cubed plus 3x squared, and then we get the gradient function by dy dx. There's a gradient, and this will give 6x squared. This will be 6x squared plus 6x. There is a square that I've left there. I put it, so 6x squared plus 6x. That is a gradient function. So at stationary point, this gradient should be equated to 0. So 6x squared plus 6x is equals to 0. So we need to find the value of x. So factor out 6x is common. So get 6x into brackets x plus 1 is equals to 0. And then we have either x is equals to 0, since when you equate 6x is equals to 0, you get that, and then x plus 1 is equals to 0, you get x is equals to -1. So the stationary points are therefore, you can see, the point at which we have the stationary point, x is equals to 0 and x is equals to -1. So to get the point, we need to give the point in terms of x and y coordinate. And to do that, since we've got the value of x is 0, we need to get the value of y. And we get the value of y by using this equation, that is y is equals to 2x cubed plus 3x squared. So we substitute x is equals to 0. So when x is equals to 0, y is equals to, just need to substitute there. When you do that substitution, this is what you get. You get y is equals to 0. Of course, that is very straightforward. Then the other value, when x is equals to -1, just substitute in the equation of the curve. When x is equals to -1, y will be given by 1. Therefore, the stationary points given in terms of x and y coordinate will be given by 0, 0. That is when x is 0, y is 0. That is the first point. And then when x is -1, y is 1. So -1, 1. So that is the stationary point. The other question, for each point in B1 above, determine whether it is a maximum or a minimum point. So the stationary points are given there, 0, 0 and -1, 1. So we need to determine whether those points are either minimum or maximum. So the stationary points are 0, 0 and -1, 1. Now we need to identify whether the minimum or maximum point, the nature of the stationary point. So we are going to use the x values of the stationary point. So x is equals to 0 and x is equals to -1. Now we need to get the second derivative in order to determine whether the nature of the stationary point. We get the second derivative. When the second derivative is greater than 0, then that is a minimum point. When the second derivative, and we differentiate twice to get the second derivative, is less than 0, then that should give the maximum point. So knowing that, we need now to get the first and the second derivative. I need the second derivative. So the equation of the curve is given by y is equals to 2x cubed plus 3x squared. So getting the first derivative, dy dx, will give 6. We already got these, 6x squared plus 6x. Then now we get the second derivative. The second derivative we derive now, we get the differential function of this one. We get 12x plus 6. Now that is the second derivative. Now what you're going to do, since you have two values of x when where you have the stationary point, the first value where you have the stationary point is x is equals to 0. So when x is equals to 0, we substitute that in the second derivative. You notice when you substitute in 12x plus 6, when x is equals to 0, you get x is greater than 0. And what did we say above there? when the second derivative is greater than 0, then that means it is a minimum point. That is a minimum point. So we go now to the other value of x, where we have the stationary point, and that is when x is equals to -1. When x is equals to -1, the second derivative, we substitute -1 in 12x plus 6, we'll get that will be negative, so it will be less than 0. So when you substitute, you get that the second derivative, and when it is a 0, that means it is a maximum point. So we have identified that when x is 0, that is a minimum point. Another stationary point, so that point 0, 0, where we have the first stationary point, that is a minimum point. And then where we got the other one, -1, 1, so -1, 1, that is maximum point. Now let's go now and sketch the curve. You know, to sketch the curve, to sketch the curve, there are a number of things that we need for us to sketch the curve. So to sketch the curve, we need, number one, we need to use the following. One, we use the x-intercept to sketch the curve. When you're sketching the curve, we don't draw the accurate curve where we need a graph book or graph paper. We don't need that. We just need to sketch, and we need the x-intercept, the y-intercept, and then we need the stationary points. The curve should contain these three elements. That is the x-intercept, the y-intercept, and the stationary points. Now we got the x-intercept in the first part of the question, and we got it. Let me go back there. We got it somewhere here. We got it somewhere here. It is there. So x-intercept, there are two values. X-intercept was 0, 0, and -3/2, 0. Those are the values of the x-intercept where the curve cuts the x-axis. The y-intercept, very fast. The y-intercept, we got it somewhere in the second part of the question. That was 0, 0. The point was 0, 0. So 0, 0. And then the stationary points, we just got those recently. In the last part of the question, we got the stationary points. They are here, 0, 0 and -1, 1. Those are the two stationary points, 0, 0 and -1, 1. Those are the stationary points. Now we have all it takes now to sketch the curve. It intercepts, the two intercepts are there, the stationary points are there. Let's go to the sketch. To sketch, you just need to just draw a rough drawing, as long as you indicate those points. So let me draw it. So the x and y axis, of course, the Cartesian plane. So that is the y-axis, and this is the x-axis. Then from there we have the origin 0, 0. Then we have -1 there to the left. We have 1. And then we have 2. We have 3. -1, -2. And then the right, we have 1, 2. So I just need to show the points that I've indicated there above. So -1, 1 is there. That is where we have the maximum point. And then we also have -3/2. That is -1.5, somewhere between -1, -2. And then there is a y-intercept is 0, 0. One stationary point is also at 0, 0. So these are there are 2 points in one. That is a stationary point, 0, 0, then the y-intercept. So when you sketch that curve, it should pass through those points. The intercept, that is the maximum point. And then The other one below there is the minimum point. And then we have the intercepts. The intercepts are, one is at 0, 0, the other one is at negative 1.5. That is negative 3 over 2, 0. And that is how you're supposed to solve that question on calculus. Thank you so much.